something to remember, strings are immutable. Once they're defined inside of the quotes, whether they're single, double, or triple quotes, they're sort of set in stone. The object inside of the quotes stays as it is. After it's declared, you can't manipulate it. So let's try B is equal to hello world. And then we'll check out the len function, which you can see here returns the number of items in a container. And we'll put B inside of that, and it should return the number of characters in here, which is 11. And then in order to use an apostrophe S, you want to use double quotes on the outside. And if you want to use quotes inside of your string, you would use triple quotes, which is a single quote followed by double quotes. Then you've got your double quotes on the inside, then a single quote and double quotes. So yeah, let's move on from there. Take a look at lists. Lists can be either letters, numbers, or strings. We'll just declare a list of numbers real quick, and each object in the list needs to be separated with a comma, and the entire list needs to be enclosed with square brackets. And we'll just see type A, which should pop up a list, and it is. So we can check the length of A, which is 3. There's 3 separate parts of the list. And let's do the same thing with some strings. Like in the slide there, we've got a volt, an amp, inside quotes, so they're all strings, and power, and then close it with a square bracket. And there we go, we got a list. So let's see, type is a list. Yes, there's more characters in here than 3, but there's individual strings. So each one of these is an object, and it counts the number of objects inside of the list, is what the length or len function does. Next, we'll try to do a little indexing. So the 0 position of S is volt. The 1 position is amp, and the 2 position is power. So as it indexes through, we've got volt in the 0 position, amp in the 1 position, and power in the 2 position. If we were to do A 0, we would expect the 0 position to be 1, the 1 position to be 2 in A here, and we'll just do it. The 3 or the 2 position is 3, so that's 0, 1, 2 position, 0, 1, 2 position, and it would continue on for indexing purposes through a list, it starts, the 0 position is on the left side of the list, and it goes on to as many, n, I guess, as many objects that are in your list. So we can redefine position in the list. So, if we were to say position 2, which is now power is equal to 277, and then we say S, and it should give us a list, and the 2 position is now 277 because we reassigned it. So you can do that with any position using indexing, and that can get pretty handy later on. Yeah, so I think that's about it for strings and lists, and now we'll just do a quick bit of programming that I thought was kind of cool. I found in the python.org tutorial, which is the Fibonacci sequence. And A, we're going to declare 2 variables, A and B, and we're going to define them. A is going to be equal to 0, and B is going to be equal to 1. So you can declare multiple variables on one line by using commas, which is kind of a handy thing too. And then we'll say while. So when we say while, this thing turns orange. That means that the interpreter recognizes it as a executable loop, and then we're going to loop through some stuff, which we'll get to next, while b is less than 1,000. And then this here is very important. It won't execute the lines below if you don't put this colon behind here. That's telling it there's more to come to this while loop. And that is going to be, we want to print B. Every time it goes through, it's going to do this. And it's also going to redefine A and B. A is now going to be B, and B is going to be A plus B. And I'm actually going to do that. Yeah, so there's the Fibonacci sequence. But that's the kind of the first look at some programming where you're using very few lines to do a lot of work. This prints out the Fibonacci sequence, and next we'll continue doing some stuff like this and get into some if statements and other stuff like that. That'll be really useful.